just insert 2 into there, and you get your 600 meters.
Exactly, 2 or 1. So
Yeah.
it's true. Yeah. So you assume it's true.
Because it follows a direct pattern.
So proof induction.
Yeah.
Okay, here you go. Oh, well, you've done 8, you've done EGK for 6.
So I did that as an example. Oh, right.
Yeah.
Fair enough.
Yeah.
So in base case, usually, like you say, you start at 1 or if.
So where have you made the assumption? Should we start?
Yeah. Sorry.
Let's start. There will be a gap in proceedings.
Okay.
I'll show that one.
No worries.
Yeah.
Thank you.
Yeah.
Well,
Yeah.
I'm making express.
Just tackling that last night and then slide.
I'm the black.
Oh, that's
Yeah, so we're following, we're trying to follow the same kind of approach I took with a couple of examples.
That we did in the lecture.
Yeah.
Yeah. Okay.
Okay, I'll
realize I'd rather throw on the coffee page, not now.
Not in good or bad.
Anybody else the proper questions next week?
Yeah.
Is everybody into CoCalc? That's the first activity.
Got the email bus home thing, and I did it there and then.
Okay, well, I mean, here.
Oh,
I'm still away from my desktop.
Mine takes
Who's Joe?
George isn't here.
George isn't here.
Yeah.
And who's?
George.
How did you say that? Is that Irish? Ilan? Ilan. Like it's an I. Ilan. I forget that. Calvin.
There you go. You're not allowed to be friends to a friend.
Get wrecked. It's also saying get wrecked. Yeah.
First of all, don't use it in
It's
a
not
store.
They don't use it for that. It's not. I didn't know that had Chrome.
I was listening to last night.
Even Microsoft don't use it.
Really?
Yeah.
I opened the world of.
I don't.
But the volume, or is the thing that has been relabeled? It's Edge actually. It says, "What's my job? You install Chrome." That was
I love it.
Okay, so if you haven't yet, so Ilan, George, and Jordan have accounts created, so they can log in straight away. If you haven't created an account yet, you'll need to go to the website, cocalc.com, and sign up. Use your university email address, and when you log in, there should be something sitting there waiting for you, theory project. So within CoCalc, the top level organization is projects. So each different thing, you can group your activities and your files into projects. You have got lots of projects. You starting off, you must have one. Here's a project for this course. Started and stuff associated to a different course, probably organized by the new project. And you can click you can click into the project and click the files icon, and there should be a week one. It's called week one folder sitting there. Jan is going to log into this same. Jan's a collaborator on my project, on the Big Theory course project, so you can log in and see this as well. Okay, so what is CoCalc? CoCalc is a cloud computing service, and the main feature about it is that it provides you with a way to make use of the SageMath software. SageMath software is, let's describe it in a sheet, it's a large mathematical software package. The main person behind it is an American mathematician called William Stein, but it's an open source software project, so anybody around the world interested in this with software development skills can get involved and contribute to the program and develop. It didn't start off from scratch, so it's a mathematical software system whose main focus is more on pure mathematics, allowing people to do computations with abstract mathematical structures. Be they, calculations, say, with familiar integers or real numbers, but it also does an effort to be able to do computations on things like graphs, things like groups, and more wilder mathematical structures as well. It didn't start off from scratch, so it started by just drawing together lots of pre-existing pieces of open source mathematical software that individual or small groups of mathematicians had written for their particular area that they were interested in. And so it started by just drawing them all together, tying them all together, and so that they were usable from one setting, and going from there. But then there's been lots of stuff added to Sage, just as Sage could. So. One of the primary aspects of Sage is that the computing language it uses for writing scripts and experimenting with it is Python, which is this widely used general purpose programming language. It's very good if you're interested in this kind of thing and hoping to make a career in some kind of area where you might be working with a computer in a technical capacity. Python skills are good to have. It's a general purpose programming language, so it's not only used for scientific research, but also just for general web development. So is everybody into the CoCalc system? Are you into it? So as an experiment, you're in the Files window. If you click on Create, and just give yourself a new Sage worksheet. So when you click Create, you've got a number of options. It gives a default file name of the current timestamp. You can replace that with your own meaningful file name. First examples. So type in a nice title and then click the Sage worksheet button. And that will bring you into the Sage worksheet. Should, when the project is working. Time out. My project seems to want to restart. Okay, so go first examples and create a worksheet. In this worksheet interface, things are split up into cells. Are you using Chrome?
Oh, that's what I do this next for.
Hi, George. Just sit over here so we got everybody together. Yeah. So when you're looking at your Sage worksheet, you can start to give it some trivial computations to do. So you can type in calculator, type instructions into it. The evaluation is to do shift enter. So when you do shift enter on this, it will take whatever Python code is here and evaluate. So 2 plus 2 is a valid input, and it should, after it starts up, it should return the value 4, of course. 4. So you do shift enter to execute something. So this is good. Calvin tried DISP Hello World. DISP is the MATLAB command, isn't it?
I'm not sure.
So this hello class, and he executed that and he got an error. Yeah, so you suggested maybe print is the default. Yeah, so print is the basic Python command to print a printable representation of whatever you put inside the brackets. The printable representation of a string, which is regular characters between quote marks, is just the string itself. You could try print 2 plus 2. Now what's the printable representation that it's going to use of 2 plus 2, do you think? print out 2 plus 2 or 4?
Currently.
I haven't made it a string yet. If I made it a string, it would print out 2 plus 2. But yeah, so 4. Basically, you can try printing anything. We can even try if we generate a group. Okay, so we haven't actually, we'll be meeting groups and the definitions of groups next week. But if we try the symmetric group index 10, we can try print the group. And we'll just, okay, so by no means does it attempt to print out all the elements or anything. It's got attached to the group, it's just got a description string that tells you what the group is. So print is a basic Python. Okay, so we'll return to some basic elements of Python in a moment. There are some other examples, Sage commands there, like a plotting command, plot sine x. Plot sine x, this is the example, and you can give a range for x from 0 to 5 pi. You should get a nice sine graph. As you're exploring Sage, getting to know Sage, there are a couple of things to get you started. There are some commonly used constructs up here in these pull-down menus. If you want to define a matrix, you can click there and it will spit out an example piece of code to define a matrix. Some example things for graphs and number theory and so on. So you might find these useful, quick plotting commands to plot various kind of things. It'll spit you out an example which you can then change. And it's got tab completion in it. So if you think that there's a command, if you thought that there's probably a command called plot, you can type PL, hit the tab key, and it should show you all the valid continuations of PL as commands. So there are various types of interesting plot commands. And let's look at plot 3D. We probably think we know what that does. So these commands are functions. Functions have a name and one or more arguments in round brackets. If you want to get a quick piece of help about a function, when the cursor is positioned just to the right of the opening bracket of a function, when you hit the tab key there, what should pop up is a pop-up window that contains the help information about that command. The help information should tell you what the command does, show you a description of the main arguments that you might pass into that command, and they always should, if it's a nice, well-documented function, it always should have several examples. Okay? And if you want to quickly see an effect of it, you can grab one of these examples, just copy and paste it, hit escape to dismiss the window, and then you can quickly paste that in, just get a feel for how the command works. Get a quick feel for how the command works and work from there. So this error message that it's complaining about, it says the name y is not defined. You may come across that when you attempt to use extra variables like this. So what we need to do to get started there, what we need to do is to declare that y is a symbolic variable, which we do by var y. Y is a symbolic variable. X, by default, X is already defined as a symbolic variable because it's used so often. So the error message didn't complain that we were using X without defined it. This probably is a little bit, they probably should enhance this to dismiss this error message because we do specify something about Y there in the argument to the plot tree. But with that, that should get rid of the error message and allow us to proceed. So again, Shift-Enter to execute the block of code, and you get a nice sine graph there, which is interactive. You can zoom in and out of it using scroll wheel or two-finger drag on a mouse pad. So, just like you do these kind of investigations with MATLAB, plotting functions, looking at graphs, you can do all that kind of stuff in the Sage worksheet. And although we're just using 1 or 2 line commands here, you can write whole programs in these little cells and then execute, okay, by doing Shift-Enter. And we'll see a little bit example of that when we look at the greatest common divisor exercise in part 2. As I say, when you look at the Moodle page, there's to get some more information about using Sage. There's an excellent resource there called Sage for Undergraduates, a book by Gregory Bard. You'll find that link to it here, Sage for Undergraduates. You should definitely check that out. And that's got a primer, some good introduction to the basics of Python programming, how to do the basic things like for loops, if statements, your own function definitions in Python, and how to manage lists and matrices and so on in Python. So that's a very good resource. In the later chapters in the book, at the end of every chapter, there's a stepped tutorial taking you through the capabilities of SageMath in that particular area of groups. So, and lots of problems associated. Okay. But it's everybody up and going with their worksheet. Let's type something into it and go to execute. Yeah. Anybody have any problems with just using that basic feature? You don't use Internet Explorer. Use Chrome. Just go to start.
I can never use Internet Explorer, so that code as well. First thing I did. I think I broke it.
I think it broke.
I think I have this.
Yeah. Everyone else was trying to do maths on the other side of the world on free hosting, and then you're asking for servers to make you something. What's wrong with electric chair?
Sorry. I clicked it. Don't advertise it in the drop down menu.
And then on top of that, you got really excited when you saw Killing Show. Why did you want to see it? That's
My
why.
project won't let it go.
Ah.
Yeah.
We have to do anything with elliptic curve?
Well, waiting about
So if you-
8 minutes.
Okay, there's more to do here. Right.
Is that the correct argument? You did it.
I clicked those the one with it.
It's
Yeah.
working.
I just assumed-
It is working. I think that means that it's working.
Have you given it a undoable application?
There's like 2 servers down now because of you.
It is.
So those are the coefficients of the standard equation, yeah? Yeah, this, our project, so your accounts are free accounts at the moment.
Yeah.
So, they don't run as fast as
Even says
Yan's.
the project runs a free server. We can give you an
It's not that expensive to upgrade your account. It's something, I think you can, they charge you something like $9 for 4 months or something. So it's not that.
Why is mine enough? I'm not paying.
No, but you're using this project at the moment, and I've upgraded this project, so you're a collaborator on this project, so you can, so you can see all the valid continuations of what you can do with an elliptic curve. Which, if I show it, should I show the optics? Probably there. Oh no, there you go. Oh, elliptic curve. That's where it's right
That
over.
is weird. I genuinely thought it was going to be something like even more
No, it's
profound than a
Rank
3D
one.
curve.
you can do some ways of
No, they're just these 3-3 type curves, aren't they?
It may ring a bell, but that's a job project. Cool. Cool.
Okay, so hands up who uses LaTeX? So who's maybe thinking of using LaTeX for the project? So, as well as giving you an interface into using Sage, CoCalc used to be called SageMath Cloud. That was its prime purpose, and the worksheet was the prime feature. But it's evolved into just a general online computing thing. You might have seen in the Create thing, it gives you many kind of options for types of files you might want to construct. If you do this drop-down menu in the file here, there are many, many different types of files. So I heard a couple of you talking about Linux there a while ago. So your project is just a Linux, its own Linux virtual machine, and you can get terminal access to it. And you can do all the normal things you do in the Linux terminal there and run various programs. It's got, so GCC is the general the GNU compiler that compiles various languages. Files.
It's supposed to compile C. Do C compile? GCC.
Yeah, it's a C compiler, but I think it also does Fortran and stuff like that. I think part of the GNU compiler collection. So you can do general kind of computing.
Notice the typo in your sheet. It says links.
Links instead of Linux. Okay, good. So fix that. And also is what's here is the ability to create and edit text files. So some of you may have used some online things like Share LaTeX or Whiteplate or Overleaf or things, and it's got a similar product here. So in your week 1 folder, there's a basic starting LaTeX file. So do you want to call that up? Yeah, good. So this is a very basic LaTeX document, and you can give a crash course, a really crash course in LaTeX. Well, first of all, you're not called Gillian, so you should change the order to Simon. Whatever's appropriate. You can change it to Jan and then see it change. Me and Jan are actually on the same project as collaborators. You can add collaborators to your project. You can actually go in and edit the same file together. You can work on different parts of the file and so on. Now, okay, so as a lab activity here, yeah, I know I'm speaking all the time, but so I suggested that we take one of the exercises from chapter 2 and maybe try and do a quick LaTeX up of its solution. So the one I've got here is question 6 from chapter 2. I didn't actually do that in the class, but what do you think?
Which one?
Should we do that one? You've got the solution prepared, Jan, don't you?
For what? Question 6.
For that question 6?
Yes.
Question 6.
Do you need question 6? Do you want question 6 on the screen? Does everybody have
your book? So it's page 29, question 6. Well, the first thing I'll do, I'll type in the question. It is claimed that, so you can just type regular English, regular whatever, into the LaTeX document.
It's LaTeX.
And this will appear typeset on the other side. Just type in some of this and then we'll explain what some elements of it are. So it's claimed that 4 times 10 to the 2n plus 9 backslash times 10 to the 2n minus 1 plus 5. It's always divisible by 5. So it's always divisible by 99. Every natural number n.
Just like normal text, but we want to do much. Python kind of.
So when you're typing away in the text, in the source file on the left, if you hit Control S to save or click the save button at the top of the screen, it saves the source file and it runs the LaTeX engine. The LaTeX engine processes the source file and produces a PDF. We're not quite looking at the PDF on the right-hand side, we're looking at a quickly rendered preview of it, but if you click the PDF tab up there, you get an actual view of the actual PDF file from where you can view it, print it, or download it to the machine you're on if you want to do anything else with it. But it's best to stick with the preview view because that renders quicker. There's a couple of extra things. So if you haven't used LaTeX before, it's a markup language. And okay, there's various technical preamble commands, but between the begin document and end document, most of the time you're putting regular English text, which it will typeset nicely, and mathematical expressions get put between $signs like this. Okay? And anything you put in between the $signs will be rendered in the proper publishing style for mathematical expressions. And letter variables will be in italics, and numbers will be rendered properly. And what also become available are several mathematical commands to produce mathematical symbols. For example, \times produces a nicely formatted multiplication symbol. Don't just use an X. An X looks kind of ugly because it's not the proper multiplication symbol. Okay? Now, you'll get errors. I got an error when I tried to use this \mathbb command. \mathbb is for producing blackboard representation of numbers, which is what we normally use for the number sets, the natural numbers, integers, and so on. So to get rid of that error message, you'll require an extra package up here. So use package AMS fonts. Type that into the top of your file. That will get rid of that error message complaining about the mathbb. Yeah, those are curly braces.
Is that what I refer to?
Curly braces, yeah. Oh, they're probably not there.
So I'm getting an error code.
Yeah. So this is because I have to use the mathbb command. mathbb. So in order to use the mathbb command, the definition of that command and what it does is contained in this package called AMS fonts. So you'll need to introduce this line at the top. Oh, I forgot to put it in. AMS is the American Mathematical Society, and they funded some of the development of software for this.
And those are what they call the
AMS fonts.
the name of the bucket, what they call it. Sorry.
Curly braces.
Curly braces.
How was that depend on it? Curly brackets.
I feel like it issue's gone now. And wow.
Okay.
That's actually really cool.
Everybody happy with that? Everybody got that kind of thing working?
So essentially it's like a programming language.
For documents, yeah.
It's so cool.
That's exactly what it is. Or for a markup language is but it is its own programming language as well. Yeah, it's adept at writing tech. And the tech system was originally written by a famous American mathematician called Don Knuth, or he's a computer scientist or mathematician. He's very famous and he's very old and very authoritative person in the field. Well, he's made loads of contributions, but one of the huge contributions is in just writing this system and making it freely available, not putting any copyright on it at all, or any, allowing everybody to use it. Okay, so should we start typing in? Let's do a compact proof of this. So this is true. So we'll do a quick induction proof. So what's the base case for this? comes down to whether you allow 0 as a natural number or not.
Does it make sense? In this case.
Well, yeah, it wouldn't be true because then you'd have 10.
Yeah, so that was my question when I was trying to solve it. Is what does the symbol stand for?
Yeah.
I mean, it stands for natural numbers, but what are the natural numbers?
So if you put minus infinity to positive.
Well, it's definitely nothing negative, but sometimes there's an argument about whether 0 is a natural number or not. That's why I try to avoid it as much as possible for say non-negative. The non-negative integers or the positive integers usually, but many people use it. So you have to clarify whether 0 is a natural number or not. So in this case, it fails for 0 because if you plug 0 in, you get, well, here you get 10 to the minus 1. So what you would get as this number wouldn't be a whole number. And so it wouldn't be divisible. What you talk about being divisible if it's a fractional number. So in this case, obviously, the author meant that 0 is not a natural number.
So the base, yes, we can take the base case as n equals 1. What does that sum to?
That sums to
99, probably. No,
495.
495. Which is 5 times 99. Okay, so that's the base case.
Killian.
Yeah.
Did you just do a copy paste a second ago?
Yeah, and then I replaced the two. I
I know
replaced the
there's some
ends
shortcut.
with, yeah. Shortcut.
2 plus 1.
Should be 1 here.
2 minus 1, yes. Oh yeah, the 100 is in the first. That's the base case. Try and do this all in one sentence. Let's do it really compact. Find out.
No, it's, well,
Okay.
okay.
So continuing the sentence, you can say if the expression with k is divisible by 99, then the expression, so 2k plus, so it's 2k plus 1. Now, okay, we're about to do some algebraic manipulation, so I'll show you another piece of LaTeX. So we've checked the base case, we've made the induction hypothesis, and then we're probably going to do a little bit of algebraic manipulation. So sometimes when you're writing things out by hand, you do this thing where you build a chain of equations down the page. Manipulation, until you get it to look how you want. And that kind of construct can be done in LaTeX using an align environment. So you have this notion of environments, and they typeset their contents in a certain way. So an align environment is what you can use to build up a chain of equations down the page. It produces a number of lines that are aligned on a particular character. The way you want to build up the chain of equations is you want always the equal sign to be right underneath each other down the page. Am I rushing ahead too fast?
How would you, I know it's just maybe an answer, but how would you move this one down?
Yeah, okay, that's an overall page design consideration. Don't concern yourself with that.
Okay.
It can be done, but what you do is you go and change the settings of the page.
And then I managed to do that. Can I do that?
Yeah, perfect. How do you do that? 0, not in.
That's just really short.
That's literally all you need to
Wow.
put in it. I just use basic common sense. I remember, wow, I actually got something right.
Something like Alice can make you do talent. My first time.
See, I've not touched MATLAB in probably like a year properly. I do a little bit of Killian, so I do a little bit in cryptography. Mm. 3 issues.
So Jan went in and changed all the backslash times to see that.
It's all in insert.
You do that? I noticed that.
Did you only notice that?
I only noticed that. But that is good.
Oh, I just changed the first two, you can copy it. It's got C dots on the text.
Yes, yeah.
I just put God.
Okay, so what do we do to this expression in order to, so we want to make use of our induction hypothesis? So basically, this expression where we've advanced the index to k plus 1, we want to manipulate it so that we see the expression with k, the one we've made the assumption about. So we can do that by, well, basically forcing the matter. I'm just going to insist that we see the original expression with k here, 2k minus 1. So what have I done in order to do that? I've split off.
So essentially that they're like the brackets.
Yes.
They don't go
400.
Yeah.
Actually, in my PowerPoint bracket, that was when you didn't write around.
And I've split off 9, 0.
Not in, and then we'll down here. And then on the left side. And then on the right side. Oh, I got rid of 2 of my issues. Oh, that's just saved, obviously. Because there's an error.
Am I doing this right? No, hang on. How am I doing? This is insane. 4 by. No.
Yeah, exactly.
How do I see? How do I manipulate this?
Well, this should be 99.
So I've got 4 by 10 to the 2k plus 2. I want 4 by 10 to the 2k. So the fraction is,
Well, this is timing, 10 to the 10 square, and this is times 10 square.
yeah,
So, range it.
yeah. Got my blank. So the fraction is what? Tell me. So I put in.
Here, you need times 10 squared, and here you need.
Yeah. I was just trying to do it in one. Oh yeah. Okay, is everybody able to follow? Roughly. You can do your own because
Gillian. Gillian's actually teaching you bad practice.
Well, I was trying to get it so we can get it.
20th century mathematician, not like Gillian, will take a pen and paper and work out the proof and then write it.
Of course.
Whereas a 21st century mathematician like Gillian just opens CodeCalc and types the proof right away.
So can you see what's happening? We check the base case. We've made the assumption here. We've examined the expression with the value k plus 1. I tried to do it too quickly there. Jan corrected me, which is good. So now what we've done is we've started to separate off factors so that we can see the expression that we made the assumption about start to emerge. So here's my 4 by 10 to the 2k, here's my 9 by 10 to the 2k minus 1, there's my plus 5. But at the moment they're multiplied, both of these parts are multiplied by 100. I just want to see them on their own. So when I remove 99 times them to just leave the ones on their own. So how do we do this? We take the thing we made the assumption about. And then the things we're separating off is 99, c dot, and what is it? What's that? 4 c dot 10 to the 2k plus 9 c dot 10 to the 2k minus 1. So then that right-hand side we're looking at, we can see now why it's divisible by 99, because the first 3 terms, the 4 by 10 to the 2k, the 9 by 10 to the 2k minus 1, the plus 5, they're all divisible. They're all equal to 99 times q. And then we've got an extra bunch of 99s here. So we can factor 99 out of all of that expression. Maybe Jan is doing that. To leave us with an expression we can reasonably claim is 99 times an inch. So 99 divided. Any error messages from you,
Just those lots of saying in the document. I'm trying, it's not.
Yes, so you're beginning, so if you look at the error message, it says, begin a line is ended by end document. So that every begin something should be paired with an end. So your begin a line should have an end line at the bottom. So the end document should come right at the very end.
Got it. So, end a line.
End a line.
So the align environment, what it's doing is it's accepting lines of input. The lines of input are ended with double backslashes. And within the lines of input, there's a special character, which is the ampersand. That's called the alignment character.
Oh, that's interesting.
And every place that LaTeX sees an ampersand in each line, it doesn't print the ampersand, but it moves the rest of the line so that the ampersands, the invisible ampersands, are all aligned down the page. So you put them right before the equal sign, say, and that ensures that your equal signs line up nicely. So then type in some kind of declaration about, therefore it's true by induction or something.
You started, this is true by
This is true as
induction.
base case, assumption, conclusion type of analysis.
It requires some effort by the reader to actually try and decipher that. It's very compact.
It's overly complex.
But it's quite common in mathematics when you write the proof that you only write the non-obvious things. So the reader really has to. So how would I go about proving it? If I wanted to prove it, and I need to do this, and I need to do that, and I need to do that, and then little steps are explained, but the general picture sometimes is missing. It's probably flawed writing, but it's quite common.
Yeah. It probably stems from originally in the printing days, pages in journals where you had to compactify, they're expensive. So they're not. And well,
I think it stands for mathematician unwillingness to actually share. So kind of write the minimum so that they would give others as little insight as possible, so that they would have the proofs told or the way of thinking. Gillian, you've got an overfull page book.
Yeah, overfull. So this is so our expressions are quite long. LaTeX, so when you first start using it, sometimes you feel the block of text is too narrow on the page, but it's done that way to make it easy to read. Wide blocks of text are hard because you keep losing which line you're on when you scan back to the start of the line. And so you can run into things like this. You can either just live with it, or you
can't.
You can live with it. What we could do is suppress the printing of the line number. So the align environment, by default, it attaches a label to every line in the equation, which allows you to cross-reference those lines later on. You can suppress that line numbering by appending an asterisk to the end of the environment name, and that works for other similar environments. And that at least will tidy it up a bit by suppressing those. You can look in your issues. Yeah, so the issue is still telling me that overfull HBox. So one of my lines is too wide, and LaTeX hasn't been able to automatically deal with it because it won't. If this was just a line of English text, it would do justification on the line and send it to the next line and so on. But it doesn't want to disturb the mathematical expressions in the aligned environment. So yeah, you'd have to make some decision about either widening the margins on your page, which is maybe bad, or thinking of alternative ways of expressing your argument. Yeah, I might be able to spot somewhere short there. Was that a backslash times or a C dot? C dot, yeah. It was a C. Okay, you took out
99 times a bracket.
Yeah, that's true. I guess the C dots are just to separate numerals, so you don't think that
910.
910 is 910. But yeah, there's no need to separate it. Double backslash ends the line.
They actually separate lines. So in plain text, you've got backslash C on. It ends lines, and you need it at the end of the last line as well. Whereas here, you don't want it at the end of the last line, because if you do, then it starts a new one. Yeah, empty. So it makes it acts as a line separator at the end. In sequence, you don't want it at the end of the line.
So cool. We've got no answer.
I do.
Oh, dear.
Okay, so on the sheet there, you see further work down the bottom. Should be all doing lots of further work, of course. There is some guided sage explorations at the end of chapters 1 and 2. I encourage you to have a look at it. Have a look at that Gregory Bard's book, Sage for Undergraduates. It's got a nice introduction to Python and so on. I've linked to a nice YouTube playlist there about writing with LaTeX on Cotal. And there's a general good link at the bottom to the Wikibooks website with their LaTeX wiki, which has kind of very detailed instructions for doing lots of different things with LaTeX. There is a project, you're giving the project talk, yeah, about
Yes.
writing with
I
LaTeX
think it's next Tuesday.
next
So
Tuesday. Yeah.
this coming Tuesday.
What time the project comes up?
I have no idea. Yeah, early afternoon. Yeah, something like that.
Okay, so we'll be making use of CodeCalc and Sage as we go through the course. You'll be able to do computations in groups with it. Yeah, okay, I guess we've got to finish for today to allow you to go.